My name is Hope Dunbar. I'm from the University of Buffalo. I'm the university archivist there, and we had a pilot project that we created to try and manage a large amount of audio. We explored consumer-level AI tools to be able to generate descriptive fields related to that audio, and I'm going to talk a little bit about how we went through that project. We focused specifically on a collection called the WBFO Audio Archive, which was a campus radio station at one point. It is a very large amount of audio, and we've been able to digitize that over time. And this aligns with sort of broader trends related to digital scholarship, automation, AI-driven workflows, a lot of the things that we've been talking about throughout this entire conference. I've been quite happy to hear so many projects that are sort of working through the challenges of AI in a way that's similar to what we were doing. That always feels nice to know that you're on the right track and you're sort of with your peers in the field. So one of the large roadblocks for a project of this scale with the size of the department that we have was available staffing. So we started to explore AI options that were available to us primarily without additional cost. A lot of the projects that you've heard about so far are pilot projects of demos that have been built. This is very much an application project, meaning we took existing tools and tried to fit those into our digital workflow to make the project move forward in a way that was accessible, in a way that took advantage of the staff and the expertise of the departments or the people that we already had within the department. And really, without streamlining this process with consumer-grade AI, this wouldn't have been possible based on our resources. So I am well aware that a lot of what I'm going to be talking about is spreadsheets. So I made some visual images to help us with this. So when I'm talking to fellow staff members, ironically less students, and talking about what AI is in a larger context, I like to use a particular metaphor. So thinking about AI as a vehicle. This can be a bicycle, this can be a Ferrari, but it's a place or a way to get from point A to point B. All of the different levels have different levels of expertise, different price points. What I'm talking about today is very much the bicycle of AI tools. This is meant to be applicable in different departments with low resources, smaller institutions, historical societies, or just departments that are maybe a little bit less familiar with AI tools, as some of us are. I like to emphasize the importance of prompt generation. So I basically created a description of what I just described, that metaphor, and these are the various images that AI produced on my behalf. I particularly enjoy the top one. So there is an intimidation factor for using AI for the first time, especially in smaller departments or smaller institutions. So we used this pilot project as a way to also teach our staff about AI best practices, which is, again, another topic that has come up over and over and over again in presentations. I mentioned previously that the collection we were using was a radio archive. That means that inherently we already had very good quality audio. The radio broadcasts were from about the 1950s to the 1990s. They covered historical movements, social events, speakers that came to the university. It was a really, really broad array. And the reason that we wanted to use AI to produce these program descriptions was mostly time. So we couldn't have a staff member listening through 2 hours of audio to write a program description. We needed some way to streamline that still involved our staff members, that still involved students in that learning process, because we do like to use students in our workflow, but still maintained our goal to actually complete the project. So how we started this is we created transcripts based on that audio. On the right, you're going to see an example of that transcript format. We used Adobe Premiere Pro mostly because we had a license to it for the text or the speech-to-text tool. Those were lightly edited and manually reviewed by students' assistants, and then we created transcriptions and prompts that were then fed into AI tools with various successes, you'll see. The process definitely needed refinement to balance the automation portion. And I always like to talk about AI as a tool, so there was always a human oversight part of this, especially with consumer-level AI. So if you've ever this is what it looks like when you ask ChatGPT and Microsoft Copilot what they look like on the right. So this is them battling it out through our A/B testing. We compared two models initially. We did OpenAI's ChatGPT and the Microsoft Copilot. We found that both of them performed relatively well. ChatGPT was a little bit more intuitive for users off the bat. Copilot really was a little bit more structured, and you needed to refine the prompts a bit more. But really, the institutional considerations is what made our final decision for us. So our IT department very strongly wanted us to lean towards Copilot. We did find that with enough prompt refinement, we were able to make that work successfully. And that's what we ended up moving forward with. So I'll talk a little bit about that decision process. So we started off very much with a simple prompt. So write 2 to 3 sentence summary of the attached document, begin your response within the segment. As we evolved the prompts over time, the prompt below, the complex prompt, is where we ended up. So this was iterative for our staff. We had 2 to 3 staff members that were dedicated to this, as well as 2 student assistants from the library science program to bring them into that process. And as we began providing clear instructions, such as requesting factual-only summaries, the consistency really improved. I'm going to give you a couple examples. So this is the simple prompt, and this is the A/B test related to ChatGPT and Copilot. I'll mention that both of these are, Copilot is the 365 instance, so it is the enterprise level that comes with Microsoft. ChatGPT 4, that's the free version. So we could only use a certain amount of prompts inputted at a time, but the pro version would give you unlimited. You'll notice that neither, or the ChatGPT response didn't identify any of the speakers. It was very broad. And Copilot also lacked some clarity and specificity. We weren't thrilled with this, but it was a good place to start. I'll also say that when I threw this into ChatGPT before this conference just to see what it would spit out, and it was even more simple. So really, really basic to the point of being slightly unusable. The complex prompt, in contrast, was much, much better. So we started the requirements as read the entire document before you begin the summary. This might seem obvious, but it was helpful to actually tell it that. Include only information that's directly stated in the provided document. Don't add outside information, speculation, generative text. Strictly stick to the facts presented. So that confined it to the document as opposed to going out to web sources. We found that earlier editions, they brought in outside opinions or maybe historical facts that might not have been known at the time period that the recording was actually made. Include specific facts, figures, names, and maintain an objective, neutral tone. Don't interject any opinions. I will say that in a couple slides, I'm going to talk about how we tried to apply this in a couple different ways with varying success. That's one of our student assistants that's actually working on the project. We had someone checking the descriptions after they were generated just to make sure that the names were spelled correctly. We got the dates right. The basic information was there as well with the description. Talking about data security and AI, I already sort of mentioned why we ended up going with Copilot, but the main drive was that it was a closed environment, so we didn't have to worry so much about the information leaving the institution. And this was a large concern for us because some of the audio material that we were generating had some copyright issues that we didn't feel comfortable feeding into an outside source. So while some of the free products are very accessible, I would strongly encourage at least getting the basic pay to keep it within a closed network. So this is one of the things that I wanted to mention. We ended up refining the prompt to tell Copilot it was allowed to fail. So we generated some sort of hallucinations, false information as we tried to apply this to different things, and actually putting into the prompt that the Copilot was allowed to fail gave it the chance to say, I can't complete this request, or this isn't. Before we did that, it would try to please the user. It would try and produce something with sometimes comical responses. So on your right, you're going to see we tried to use this to basically have Copilot pull from Library of Congress subject headings based on the transcriptions. And we thought this would be a great application. Initially, when we looked at it, they looked really promising. And then when you actually click the links to the URLs where they go, they do not. They are wildly off. And And this is also why you need that step of human intervention to make sure that what they're giving you is actually what you want it to give you. So with that, I want to talk about a couple things. And the image on the right is the actual spreadsheet that we're using just to compile the descriptions. And these are going to be inputted eventually into the American Archive of Public Broadcasting as a large radio collection. So I like things that I like and I don't like about this project. I would love the Ferrari of AI. I would love to have that really large, robust tool that can do everything that I need. That's not within our reach right now, or at least my reach, my direct reach. So consumer grade tools gave us an entry point to be able to teach AI literacy to our special collections staff that had also never touched any AI product. That's not something that they were familiar with, and that was a way to sort of open the door. The tools significantly reduced metadata creation time by feeding in those transcription summaries into an item that would just summarize it, spit it out as a program description. The project really wouldn't have been even possible without it. And I think that AI should complement and not replace human archivists. I mean, I know that this is a crowd that will appreciate that as a sentiment, but it's worth saying that even AI tools are tools. They still need that human interaction and intervention to make them successful. So with that, again, my name's Hope Dunbar. If you have any questions about the project or anything else that we've done, I'm happy to talk about it further. Thank you.
Hello, everyone. My name is Rachel Sneese-Myers. I'm going to be talking about how we're leveraging AI for improved transcription in special collection and academic libraries, but specifically at Georgia State University. So at Georgia State University, we are one of the largest universities in Georgia. We have a relatively reflective special collections, roughly 8 curatorial areas that span various topics like Southern labor, popular music and culture, women's history, gender and sexuality, as well as Atlanta history. And across those topics, we have conservatively over 200,000, but realistically, we're probably over 300,000 AV assets. And of those 200 to 300,000, only 2,500 of them are available online. And Digital Projects, which is my unit, is part of Digital Library Services, aka Library IT, and we are responsible for making these available online. So for AV assets, we traditionally either have not had transcripts or we have transcripts created for us by vendors. Our oral history assets were generally the ones that we had the vendors pay for, or we paid the vendors for, and everything else we really didn't have transcripts. Every oral history is processed using oral history metadata synchronizer, and it was pretty time intensive. For assets that weren't oral histories, we did time subject indexing. For the oral histories where we had transcripts, we synced them. For anything that wasn't going into ohms, so our conference recordings, our radio spots, we put them into YouTube and we try YouTube's native captioning with mixed success. And we also tried using Adobe Premiere Pro during one of our recent grants to digitize over 900 AV assets with some limited success. So as you can expect, we had a lot of problems, like everybody else. Using vendors was expensive and still required further processing on our end. We used volunteers. We had varying level of quality and no reliable timelines. So who knows when we were going to get those done, which impacted my timelines. When attempting to use Adobe, we had very long processing times. Some of our assets can be 10 hours long, and so we just let a computer run for hours and days trying to get these processed. The accuracy also was pretty questionable. We had recordings from the 1950s, and it would tell us, hey, President Obama was speaking. So we were like, okay, that's not very helpful for us. There's a lot of fixing that has to go. Also, our OHMS instance, the Oral History Metadata Synchronizer, is iframed into our digital collections. So any transcripts, indexing, they were not searchable through the platform, which created redundancy in metadata for us and a lot more work. And from a general accessibility standpoint, we could do better. Due to the fragile nature of many of our AV assets, digitization has become one of our priorities. So we knew that we had to create a better solution going forward. I had attended the Fantastic Futures Conference in 2023 and learned about OpenAI's Whisper. I had also reached out to the University of Georgia to see what they were using, since they have a much larger AV collection than we do, and they are our sister organization. They graciously ran a couple of our recordings and provided us with some samples. Those examples were enough for us to try and experiment ourselves. During this time, I also facilitated a conversation with our special collections team. And we had a conversation about ethics and privacy on if we were to embark on this AI journey. And from their perspective, they said, we're okay with it, but it can't be leaving campus. It has to be locally hosted, which we were like, okay, that's fair. And that's what we really want to work towards. So to figure out how to make this happen, all of the units of digital library services, which includes myself, digital projects, web services, and systems, we assessed our situation from a technological perspective. Since our graduate research assistants, also known as GRAs, are the ones who process our AV assets, we knew that whatever solution we came up with must be available on multiple machines. They work at the same time, and sometimes we can have 4 or 5, depending on the project. We also needed it to be able to access the internet and our network drives, because that's where all of our files were stored. Also, our GRAs work on older machines out of maintenance, so they're not the best machines that we have, I'll be honest. So we knew that those machines are not going to work for a heavy-duty processing. We also spoke about having a machine or 2 off network, but our central IT departments have restrictions on that. And we also can't use command line because they also have restrictions on that. So we were trying to figure out what we were going to do. I was also keeping in mind this conversation with special collections about the privacy aspect. And also ethically, we don't want to put words in people's mouth. So if we have a transcript that was inaccurate, we did not want to publish that. So we knew we also had to have a human in the loop element. So from that conversation, we determined that we were going to need to use a user interface. We determined that that was necessary to be able to use Whisper. We identified 2 existing user interfaces that utilized Fasper Whisper, which is a derivative of OpenAI's Whisper. The one on the left is Whisper Web UI, and the one on the right is Whisper. We tested them both with Web UI first. So we found that we liked Web UI's customization, diarization, or also known as speaker identification, integration, and it can process YouTube playlists. One of our goals is to actually reprocess everything that doesn't have a transcript that's already online. We didn't like that there was no progress information. So when a recording became stuck, we had no idea until later. There was also no database functionality. So if you accidentally close the window, if you refresh the window, if the computer restarts because it has to do an update, we lost everything. So we had to reprocess again. The biggest issue was that although the transcripts were far superior to what we had produced with Adobe or YouTube, they would still need editing because of that human in the loop aspect. To address these dislikes of the web UI, we tried Whisper, which was number 2. We liked that it addressed the database and the editing functionalities that web UI did not. And we could not choose the model, but we cannot choose the model, we cannot customize it. So if that model was not the one that was going to work the best for our recordings, whether they were from the 1950s, whether they were from Zoom, whether they were in person, depending on how southern of an accent we have, because we're in Georgia, we couldn't play with the models. It also didn't have diarization, and we couldn't batch upload like we could with web UI to really optimize our workflows. And we also couldn't make batch edits, which was problematic for speaker identification. So after our experiments, we knew that we needed and what we needed and what we wanted. We wanted a UI with database functionality, customizations of settings, and diarization. We also knew that it had to be able to process both files and YouTube videos, as well as one of our long-term goals, again, to reprocess all of our AV assets, so it had to do YouTube playlists as well. We also needed the platform to export SRT, VTT, formatted text, and unformatted text. We would be uploading the formatted text to our digital asset management system, and the unformatted text we used for text searching, because we had character limits, so it was just easier that way. We also wanted the platform to auto-save the edits. So that way, if the window refreshes, the computer decides to update, all of that work was still there. So anytime one character was changed, it automatically updated. We also wanted to update the speaker in batches. So that way, you don't have to go through every single line. Some of our recordings are 2.5, 3 hours. You don't want to do that one by one. Eventually, we also want to create a front end and an admin portal for the event where we expand the user base to outside of digital projects. So that way we can optimize what's processed when, and if we decide, no, these are not priorities, we can manage that on the back end. So to meet all of these wants and needs, our web services created WhisperScribe for us. It is built on the Django framework because the core Whisper libraries are written in Python, even though that is not one of our strengths. And it uses Bootstrap for styling. We use the faster Whisper model for the transcript generation and PyEndNote audio for diarization. It runs on a machine with CUDA technology, and again, it's one of our very old machines, but it works pretty well. We upload either files or we can spin a YouTube link and get a transcript and with speaker identification if selected in an editable interface. There are 2 windows within the interface. The first is the submission page where we select the model and the language-enabled voice activity detection and change our max segment length and time if necessary. It's not something we do, but if we absolutely have to, we can. This window also shows a list of assets present within the platform. So whether it's processed and queue, it's all there. The second window is within the editing interface, which is on the right. Users can add in the segment text if necessary. So if we have speakers speaking at the same time and Whisper misses it, we can add in that segment as well. We can edit all of the text, the speakers, and the timestamps as well. So again, when it misses something, we're able to edit all of those timestamps, which is very helpful. And again, the batch editing for the speaker labels was very important. There have been a lot of challenges with this project. The web services team is small. There's about 3 of them, and they manage multiple applications and servers on top of all the development work here. So balancing the time dedicated to the project while managing day-to-day maintenance and tasks was difficult. They also had extended leave during this project, which slowed progress as well. From a technological perspective, the choice of Django required a steep learning curve for the team as they had limited experience with it. The functionality priorities shifted over time as we started to use it as well. Unfortunately, I found new wanted functionalities within the platform for future development that had ramifications on what they were doing in the moment. So they had to change priorities for things that would happen in the future as I brought them up. I was not their favorite those days. The graduate research assistants also identified user interface changes that would make using the platform easier, which also became bigger priorities because we want to make it easier to use now versus in the future. And again, these changes required priorities during development. Having used the platform for a few months, we've done a preliminary cost assessment of using vendors versus creating the transcripts in-house. These are all very rough estimates. I had to deduce a lot of things and did a lot of math. So we estimate that our vendors spend about 6 hours of transcription per 1 AV hour at $40 an hour, which totaled roughly $240 an AV hour. These transcripts were not time-stamped and would need an additional processing in-house using OHMs, as well as metadata creation, which adds costs on the back end. In-house, using WhisperScribe, it takes roughly 4.5 editing hours per AV hour. They make $23.50 an hour, a lot cheaper, which totals about $105.75 per AV hour. This does not include processing time prior to and within WhisperScribe, which takes roughly an hour based off of their estimates. And a lot of times they'll process one on one machine and get started on the other one, so there's a lot of overlap. The output is time-stamped transcripts with the speaker identification when appropriate. During the editing time, our graduate assistants are also taking notes and writing metadata. So they're saving time in that aspect as well. As they're going through, they're fixing, they're taking their notes. It's a lot faster for us. These numbers do not take into consideration the amount of money and salary it has taken to develop and maintain the platform. Factoring that number in, we'd probably be looking at it being cheaper some amount to a vendor in the short term. In the long term, I believe that eventually, as we reprocess all of our AV assets that don't have transcripts and process new assets coming in, because they're always creating oral histories, the amount of time it would take to hire a vendor, or the amount it would take to hire a vendor versus in-house cost would intersect relatively quickly. So being in-house would be a lot cheaper in the long term. Right now, our development focus is on enhancing the current functionality. We're still working on processing the YouTube playlists because that's proven to be a little tricky. And what that actually looks like is within the platform as it processes them through. We're looking to redesign the submission page so that it only includes the queue and active Whisper Pia note processing assets and more transparency on the processing status, which would provide real-time updates on what stage each recording is at. A second page will have all of the Whisper processed assets that either need to be edited or are currently in the editing process, so that way it's a lot cleaner. We're going to include a way to filter, sort, and organize these recordings, possibly using tags, so the specific method is to be determined once we actually get into it. We're also looking to change the editing interface to be more user-friendly, like listing timestamps as hour, minute, seconds instead of thousands of hours. It's been great. My poor students have been trying to transfer over, and that was their biggest request. They also would like us to change the color scheme and the icons to be more descriptive of the function, to name a few of the other changes. Long-term, for version 2.0, we're investigating how to sync transcripts that already exist but do not have timestamps. With the Smithsonian, we've been having preliminary conversations with the Smithsonian on how to do this because they presented on it in 2023. They haven't acted on it yet, but they're currently developing it. So hopefully we'll be able to do that as well. We're also looking to include named entity recognition and summarization down the line to cut down metadata creation. We've made WhisperScribe freely available to any institution who would like to use it. You can use our QR code on the right to access our GitHub repository. We also welcome any institution or person who may be interested in collaborating on the development of the project, have ideas on functionality for us to improve WhisperScribe, or give us some expertise to help us out. Thank you.
Okay, so my name is Doug Boyd. I direct the Louis B. Nunn Center for Oral History at the University of Kentucky Libraries. I too asked AI to generate an image that I think the prompt was combine a Prohibition-era SpeakEZ with a digital archive that specializes in audio-visual, and make sure Kentucky bourbon is on the counter. And it did it. So this is not the Nunn Center, although my dean is here and our building is slated for renovation. So if you're looking for design ideas, that could be it. So I'm going to talk about the SpeakEZ system that we have created. The Nunn Center, just for some context, is been going for 51 years. We have over 19,000. We'll hit 20,000 this summer. We're now accessioning over 1,000 new interviews a year. And so we've ramped up in a very big way and quite frankly have scaled out. We cannot actually keep up processing. You know, I think just context-wise, I've always been frustrated by the general lack of accessibility of oral histories, which, you know, it's a hard resource, really. But in terms of, you know, I guess that context is where I created OHMS back in 2008, 2009. Open source web app to enhance access to online oral history. And, you know, we've been using OHMS a lot at my center. OHMS basically does a few simple things. It connects a textual search to the moment. Now, keep in mind, OHMS was created before there were sort of time text standards. So we really had to come up with our own, which as of December, it's now a VTT-based system, which I'm very excited about. but basically connecting text to the moment in the audio, but also has this indexing feature where you can create segments that you can click on and you can search, and it's a range of metadata opportunities within each segment that include partial transcript, title, story synopsis, keywords and subjects, GPS coordinates, that kind of thing. So maps come up, which is cool. But this is an example of essentially like a finished interview in our processing workflow. We get a full indexed OMSed interview. We don't necessarily transcribe everything because we haven't been able to afford that. But you get a brief description, keywords, LC subjects. That's what usually happens at the end. OMS, though, is a manual process. As you talked about, it's manual. Since my first days in oral history in this business many years ago, we have prayed for speech recognition that would be more efficient than the humans, and it certainly has happened now. I've been testing it for, I'm not going to play the clip, but I've been testing this for 10 years, speech recognition. Every year I'd come back to it and would throw something at it. And this is an example where we actually paired up this interview with Fawn Weaver, who's owns the Uncle Nearest distillery in Tennessee, not bourbon. And it compared the machine to the human. We paid the human double to our vendor to actually transcribe this interview. And this is a classic example where the machine implodes, right? It's skipping ahead. Where the machine implodes. They're talking over each other. Wow, what's going on? Where they're talking over each other. Somebody laughs and somebody says, yeah, love Clay. So, you got a little bit of forgiveness there for the machine because they're talking at the same time. Except in this case, the machine beat the human. The machine actually got it right, and the human, who we paid double to go through this transcript multiple times, actually got it wrong, which pretty much blew my mind. So the SpeakEZ system that we've created at the University of Kentucky is made up of 4 different modules, and I think I was kind of always regretted not coming up with a better name for OMS, the Oral History Metadata Synchronizer, so I'm overcompensating. And so this SpeakEZ is made up of the verbatomizer, the describalizer, the OMSifier, and the riskalizer. I've been told by my boss that these are to remain code names. But essentially, we're going to set out to transcribe and run every single one of our interviews through this system, and super excited about it. I skipped over the synchronifier. I'll talk about that in a second because it solves your problem that you're talking about. So the SpeakEZ system, this is essentially the workflow. We're running Whisper, and it is verbatimized. Then it goes to the describalizer, where we're extracting some metadata, OMSifier, through the riskalizer, and then out. For the record, nothing goes public until a human has vetted it extensively. We wanted to design a system that was completely in-house, that was contained. We didn't want any of the oral history material, especially, in its raw form, to be something that was teaching other LLMs anything at this point. So we deal with a lot of sensitive information sometimes in these oral history interviews. Sometimes we don't even know what's in these oral history interviews, so we didn't want to relinquish that control. So you upload the video. I made this a video so you could see. I'm very excited. The processing of it is a little LP turning. I'm very excited about that. It seemed like a really good idea at the time until you hit the machine with 300 of these, and there's 300 of the things, and then it's actually dangerous to look at. So we're going to refine the interface, but for right now, it's working extremely well. So the verbatomizer, let's talk about that. Well, it does what you think it does. But the output is going to be a VTT file and a TXT, obviously structured in the ways that we're familiar with and need it to be structured. I created it in a way that was going to be interoperable with OMS, now that OMS is VTT based. So the export of this system works in tandem with OMS. So the synchronifier really gets at this issue that you were talking about. What about all those legacy transcripts that we paid humans to spend hours and hours and hours to make sure that we're perfect, but they don't have time code. So the synchronifier, I'm super excited, is going to verbatomize like normal, but then prompt you, and it's so amazing. It prompts you for a transcript. You upload the human-generated transcript, and it basically looks at both and figures out where the time code from the raw goes in the cooked interview, so to speak, and then you're working with a finished transcript at that point. So that's actually one of my probably favorite features of this system, is that, because it really does in a very simple way. So this is, again, just a quick look at structured text with time code that we're getting that's coming into OHMS. So at the same time, we have incorporated into OHMS, in this transition to VTT, a VTT text editor, so that you are able to actually take raw text that has come out of Whisper and bring it into your OHMS account. And now, instead of OHMS being somewhere where you import a finished transcript, OHMS is now is a place where you can actually finish that transcript. You can go in and make all those changes that we all still need to make. Whisper is not perfect. It's fantastic. But it does all the things like the batch speaker change, find and replace type of thing. You can resync moments if you need to resync moments. You can create notes. You can create really pretty robust series of annotations. OHMS used to have this footnoting feature that was very clunky. Now it's got a very sophisticated footnote or annotation feature that's really, really cool. So the Describalizer does just what you think it does. It's going to generate pretty extensive archival descriptions. It already does. I'm talking about this in the past tense. It's present tense. So it's going to extract some keywords. These will need some refinement, right? It's not perfect. The description was pretty close to perfect, I would say. But a lot of keywords in there that we aren't going to use. And so, but it creates these new opportunities, and the Describalizer is going to, it runs the named entity recognition. So you're going to get the classic, lists of people, organizations that are mentioned in the place names. It automatically harvests the GPS coordinates with the place names. Again, not always perfect. So it may need editing, but very powerful. This adds some new dimensions to metadata that have really got me thinking about what would be useful, because now we can. And one of those is, wouldn't it be great for users if they could actually, with a click of the record, see a list of all the interview questions that were asked over the course of an interview? So not currently something that you see in any kind of metadata schemas, but I think a fantastic way to give you a real sense for the quality of that interview. So we are embarking on that as well, which has a trickle-down effect of having then to actually change our, collection management system as well, and update that, as well as our delivery access point. So similarly, OHMS is adding in, thanks to an NEH grant that we're in the final stages of, thankfully, NER. So OHMS is doing NER for free now, and that's also something that you're going to be able to edit in this transcript editor. So verbatomizer, Describalizer, synchronifier, the OHMSifier. So the OHMSifier creates basically a draft OHMS index. And darn it, if it isn't like exactly using titles that I would teach in a workshop on how to index oral history using OHMS. It's really remarkable, its ability to summarize at the segment level. So we are creating draft OHMS indexes. Again, the humans at the Nunn Center are going to go in and they're going to clean these up and use the draft index as a starting point so that we can basically create efficiencies so that we're not adding to our total time for processing oral history now that we're adding in the transcripts. So, with OHMS, we realized oral history out there isn't a perfect resource. It can be sort of problematic. It's kind of a privacy shitstorm, right? Like oral history has a lot of stuff in it that could pose potential risk. So over the years, we just have tons of examples of this. And the Nunn Center has had to really, really hone a system in-house for identifying some of these things before they go online, which is why I like the process of OMSing in terms of indexing. But like we're consistently getting admissions of crime, accusations of crimes, personal attacks, discussion of love triangles, which name names, discussions of addictions, discussion of other people's, I did love triangles again, so I feel really strongly about that. It's very triggering, I guess. Mental health, sensitive information. I was just over breakfast telling the story that at some point a master distiller revealed a bourbon recipe. And, it's a long story, but I really thought I was going to be assassinated. The company called and they were like, meet me in warehouse H. And I did. And the guard at the guardhouse, when I pulled up to the distillery, said, I didn't think we used warehouse H anymore. So we've developed the riskalyzer. So the riskalyzer actually is going through. And so the riskalyzer is really fantastic. Like I love it so much. It actually provides pretty extensive. Right now it's probably too extensive, but I'd rather have it err on that side, where it is identifying potentially problematic things. This is an interview I did several months ago. And it really, we certainly have worse, but that's a good example of the flags that it's looking for, which I'm pretty excited about. So it's an in-house closed system. We do now need to build systems for being able to ingest new forms of metadata. We need to rethink what are the best practices for these new forms of metadata we're going to be creating, like the oral history questions and the GPS coordinates. Question of do we do sentiment analysis on this? Like the AI team was like, let's do sentiment analysis. Let's do it. Sentiment analysis is basically analyzing the interview for emotion and whatnot. And just haven't been able to bring myself to do that yet because I would not want to be interviewed by my center and then look at what machines think I'm feeling at a given time. So we have not done that. We've resisted that. But we need to build systems to assess and edit the machine-generated text. We did that with the transcripts and OMS. That's a free system. You can use that transcript editor, whether you're a full OMS user or not. It's pretty fantastic. But what about the descriptions? What about all this other metadata that we're creating? So the Nunn Center has their plan to create a series of dashboards in our collection management tool that will actually present the machine-generated and the human-generated and allow you to create a consensus description. And the same with keywords. You're going to be able to select what the machine chose and what the humans chose, because we have interviewers submit metadata that is really quite good. So we want to create the mechanism for being able to allow for both. I think assessment is really important to this too. We need to pay attention. We're already going to be paying attention at speech recognition success. You can calculate the word error rates and things like that for the models that you're using, which is great. We're really comfortable with the model we're using right now for it, but that's going to change, and we need to stay on that. But so much of the subjective component of cleaning up the metadata and things like that, we need to be paying attention and assessing the quality and the bias that's going into the metadata that's being created. And so I haven't wrapped my head around that yet. That's going to be in another future phase, trying to figure out how do we really assess these outputs in a continual way where we can adapt as needed. Making the case for humans and thinking about whether the humans are in this role, because we could run this whole system and put that metadata out there and not have a human really touch it from that perspective. And we're not doing that. We're committed to actually having somebody actually go through all the records before they go out. We're not going to put all the transcripts out online, but we are going to make them searchable. So it will become part of that global search, assuming the riskalyzer says it's okay, to be able to include that text in the back-end search. But with everything being transcribed, I'm very excited about the discoveries that we're going to be making. I think this is also the big question is, is this a system that other people are going to want to use? And I think with OHMS, we originally created it in-house for us, and then IMLS give us a national leadership grant to make it open source and free. And now it's being used by a lot of people in a lot of places. But is this something that other people are going to want to use, or is this something that other people are going to craft their own solutions to do that work better for them? So, show of hands, is this something that other institutions are going to want to use? Few of you? Yeah? Okay. Little parts like the synchronifier, I can't wait for that. I think people are going to really, again, I'm talking about it as though it's in the past tense, and it's not in the past tense, it's the present tense. I'm excited about it. So, okay, well, I'm easily findable if you have any questions, if you want to talk about anything. And so I think we'd stop and ask or have people ask questions. Let's go back to your original slide.
Sure. I love your naming. the naming is really great.
Thank you.
Nathan Tallman, AP Trust. Have any of you talked to Vanderbilt about some of this work?
Yeah.
Vanderbilt has the TV news archive. They've got petabytes of TV broadcast news footage. They did an ACM webinar a few months ago where they've done this process for all of the petabytes of TV news that they've done. And one of the things that they also did in their process was sort of some fine-tuning training, because they was having trouble picking up names, was sort of the things that was the most difficult for them. So they sort of extracted all of their transcripts per time period and created sets of names based on dates and fed that in, which really improved a lot of the name recognition, but just might be worth a conversation with them because they did some similar work. Fantastic. Thank you all.
Hi, John Dunn, Indiana University Bloomington. This is all terrific, really exciting to see how it all evolves. Question for you, Doug, about the synchronifier. I think maybe you and I have even talked about this like 10 years ago or more, but my understanding, I'm not an oral history expert, but my understanding is kind of in the pre-digital age, often at least for some oral history projects, the transcript was kind of the primary object, right? Not the recording. And because of some of the issues you mentioned, that transcript might often be cleaned up, have redactions, corrections, etc. Can the synchronifier, in terms of doing forced alignment against the recording, can it deal with transcripts that are less than authentic to the original recording? How well does it work?
Yeah, we've had several. Can you hear me? We've had several of those because we've been around 51 years and have transcripts that were made more readable. Because that's essentially So so far the sort of interpolation that it's making has been pretty good. It's not absolutely perfect in those situations, so it might take some micro adjustment in terms of the time alignment. But it's been so successful that I'm reasonably confident that we may trust it completely.
Do you know, is it using an existing underlying tool to do the alignment, or is it all?
I think we created something from scratch, which I wish they hadn't done necessarily, but because I'm collaborating with the University of Kentucky's Center for Applied AI, which is kind of an upstart center that timing-wise was great because they're looking for partnerships, and I pretty much had this thing envisioned since 2019. So it was perfect. But yeah, I think they created it from scratch. So.
I hope it's okay. They're recording it, so they want you on that. That's good. Thank you.
Sorry about that. I just had a question, please. Can you tell us a little bit more about how your labeling generated metadata, both internally in your catalogs, etc., but also in any external contexts? I'll just pass this on.
Do you want to take this one first?
Sure. But I talked a little bit about the dashboards that we're creating on the back end, where it's going to, we're creating fields where what was submitted by a human is going to be labeled as such. What was created by the machines is going to be labeled as such. And then there's going to be the ability to create a consensus between that. So we're not necessarily going to make the raw machine-generated text out there. So it's all going through a human. So I think at this point, probably not going to label that as such because it's really being used as sort of a tool to instigate better metadata. But I think we're going to face the problem, and I think this is going to happen with transcripts as well, where I think a lot of entities are just going to be like, well, Whisper's good enough. It's 97%. We're just going to put it out there. And I think that's where we really, as a field, have to think seriously about how we do label these things. Yeah.
We're currently crafting a statement for any oral history that or recording that we do use WhisperScribe. So that way we will state like the original transcript was created using AI and it was edited by human, just so that way we have that transparency. But everything else is pretty much human at this point. Eventually, once we do get name entity recognition or start using summarization, we'll have a note about that as well, because we're very committed towards the transparency of it. We just don't have those statements crafted yet.
Same for us. So we're coming up with statements that are going to go along with those digital objects to basically describe the way that we use the project to create the description. That may not be in every description that we create. It'll be on a higher level, just so we're not repeating that statement over and over and over again. But we're aware that needs to be a transparent process, especially if we can't look at every single word that's been created. We want to make sure that everybody knows what they're looking at and they can look at it with that lens. Well, thank you.